all. My name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is image processing. Today I am discussing about color transformations. So, what is color transformation? What is the need of color transformation when we are using? What are the techniques we are applying for the color transformation? So, black and white to color is a one transformation, and color to black and white is also one transformation. So, here black and white colors we are calling as a gray colors. So, color image to the gray color image and gray to the color image. How we are converting? So, that is called color transformations. So, color transformation is useful to think of a color image as a vector valued image where each pixel has associated with it as vector of three values. Each components of this vector corresponds to a different aspects of color depending on the color models being used. For example, an RGB means red, green and blue. So, RGB model, the three values in the vector respectively denote the red, green and blue components of the color of the pixel. Any of the color that is we are considering as a RGB. So, this is I am converting to the gray image. So, in HSI model, the three values in the vector denote the hue, saturation and intensity. So, HSI, hue, saturation and intensity. So, RGB is one type of image, that is a RGB and grayscale and HSI. So, these are the techniques, these are the images we are converting from one form to the another form. So, when we are using, so image transformation or color image transformation is a vector valued image. So, the pixels are associated with a vector of three values. Three values means if I am taking RGB, it is one value. If I am taking HSI, it is another value. When I am taking the vector of RGB, that is a red, green and blue. When I am taking the HSI model, hue, saturation and intensity. These are the another technique of the color image. So, how we are finding? Suppose I am taking RGB model means red, green, blue. So, the image is a form of only these three colors only. So, these three colors are in the vector form, that is the red, green, blue components of the color of the pixel. But the HSI model, it is another type of model, that is a vector denote that hue, saturation, intensity of the color image of the pixel. So, we can think that the color transformation as a transformation of vector SI equal to TI of R1, R2, R3 is equal to I equal to 1, 2, 3. But what about R1, R2, R3? Here R1, R2, R3 represents the color components of the input image. S1, S2, S3 represents the color components of the output image. So, here SI equal to output image P is the transformation technique and R1, R2, R3. Input image pixels. So, output equal to transformation technique of input image. So, when we are applying the transformation technique to the input image, that is the converting the output. These output in the form of RGB or HSI model. So, I am applying the RGB or maybe I will apply the HSI. HSI means hue, saturation and intensity. Otherwise, red, green, blue. So, I am applying the HSI vector. It is a one type of vector. It is a one type of vector or transformation technique applying for the input image. So, maybe input image is a gray or input image is a color image, what it may be. But I am applying the HSI technique, HSI vector transformation to the input image. So when I'm applying the transformation technique to the input image, I'm getting the output image. Okay, that is. It is one example of color image histogram equalization. So what is the histogram? Input is a RGB, that is f of m comma n. Output is also RGB is g of m comma n. So what is happening? But f of m comma n equal to g of m comma n. Input is converted to the output. But what is happened means when I'm applying the transformation technique to the input image, then only I will get the output image. So what is the transformation technique? Here the transformation technique is nothing but a histogram technique. Here I am applying the histogram technique to the input image. Then only I will get the output image. So here RGB is converted to the HSV. Here HSV is converted to the RGB. So already we know that red, green, blue and hue, saturation and intensity of this one. This HSI is converting to the RGB. So that is the process. So what it means here, FH of m comma n and FS of m comma n are the two values. But here histogram value is a transformation technique. Transformation process. Okay. So RGB image is a input image and getting the RGB image is a output image. But what is happened means input RGB image is a maybe the noise or maybe a grayscale or maybe a gray color or maybe a different colors are there. But output I have to get RGB of red, green, blue in the form of RGB only. So maybe I will change the intensities. Maybe we will change the noises. We are reducing the noises. So here what is the process means? Histogram process. Histogram is a transformation technique or vector function applying for the input to getting the output of RGB. So here one input image is there. Here it is the output image. So what is I'm applying means histogram equalization. So input image with histogram that equal to output. So input with histogram is equal to output. So what is happened means here we can observe this one. It is the color is somewhat dull. Maybe some noise is there, somewhat dull. So I have to increase the brightness. I have to increase in the color intensities. That is my opinion. So output I have to get as a brightness or intensities I have to increase. So what I have to do means I have to use HSI, hue, saturation and intensities. So I will change the intensity values. Then the brightness will be increased. Then I have to get the output of this image. So how I am getting input to output means I am using the histogram equalization. It is the transformation technique. Transformation technique. Here I am used transformation technique. I am used to converting to the output image. So original image is converted to the output image is a histogram equalization. So input is converted to output. Original image is a input image. Histogram equalization is the output. But what I am applied means here I applied HSI technique. So it is another one. Histogram equalization with saturation adjustment in the HSI color. Already we know that now. What is HSI? Hue, saturation and intensity. Hue, saturation and intensity. So it is one image that is a figure A and it is a figure B and a figure C. So what is happened means in the figure A, I applied hue. So it is a graph, x-axis and y-axis. So the values are like this. So when I applied the hue to the input image, so what is happening? So what is my aim? Means my aim is histogram, means HSI. I have to apply the HSI to the original image. That is a HSI. So histogram transformation technique is nothing but a HSI. Here I am applying. So Figure A applied hue and figure B I applied saturation. Applied intensity. So hue, saturation and intensity, HSI. So this HSI I am calling as a histogram process. So hue, saturation and intensity, HSI I applied to the image. So what is output means the histogram output. So what I need, I am getting the output. But what is the technique I am applied means HSI technique. Hue, saturation and the intensity values are applied here. So it is a histogram before processing of the medium. That is a value is 0.36. So here histogram after processing the median is a 0.5. So I am converted to the histogram value is 0.36 to 0.5. It is changed to 0.36 to 0.5. Is increased or not? Yes, the value is increased. But what is happened means I applied HSI, hue, saturation and intensity values I applied, then only the values are changed. And although another transformation technique is operations are involved in the HSI space, the computations involved in conversation back and forth from RGB space more than offsets. Any savings in computation in HSI space. This is analog to grayscale navigation. So analog to grayscale means input is a analog converted to the gray. Gray means in the form of black and white. In the form of black and white. So when the grayscale case, the transformation is useful in enhancing the in detail embedded in dark portion of a color image. But the computation can be easily implemented in the RGB space. So there is no simple equivalent of this in HSI space, and approximation is possible. So here also I am applying HSI technique. But what is the difference? Means input is a grayscale, means black and white image, converting to the color image. Maybe the color is in the form of RGB. So grayscale, grayscale is navigating converting to the color image in the form of RGB. But what is the technique I'm using? I'm using here HSI space. So that is the reason it is the operation of involvement of HSI. The computations involved in conversion back and forth from RGB space more than offsets any savings computations in HSI space. But the analog to grayscale navigations as a grayscale, the transformation is useful in enhancing in detail. But what is the completion? The complementation is the implementation of RGB space. But grayscale is converting to the RGB. So analog is a converting to gray and gray is converting to the RGB. So it is a no simple equivalent of this HSI space and approximation of this possibility. So what is the equation for transformation? It is a simple transformation involving intensity scaling. So G of m comma n equal to K into f of m comma n. Here G of m comma n is a output equation. Input and K is a transformation. Transformation technique. Transformation technique, that is a K. So where 0 is less than K, less than 1 is a scaling factor. But when I am going for the HSI, what is the value of K value is equal to S1 equal to R1, S2 equal to R3, R2, S3 equal to K into R3. So S1 equal to R1, S2 equal to R2. What is the condition means when I am going for the HSI. So when I am going the HSI, if I am going to the RGB, I am applying the technique as a RGB, not HSI. So what is the values? S1 equal to K into R1, S2 equal to K into R2, S3 equal to K into R3. But here there is no K value here, no K value here. But here only for S3 only I am getting the K value. But when I am going to the RGB, here all the constants S1, S2, S3, I am getting the three constants. Okay, three transformation techniques applied for the each RGB. RGB. So it is about the RGB. When I am going for the CMY, S1 equal to K into R1 plus 1 minus K, S2 equal to K into R2, S3 equal to K into R3. So plus 1 minus K3. So here K is a transformation technique or K is a constant value. When HSI is there, S1 equal to S2 equal to S3 equal to K into R3. But when I am going for the RGB, S1 equal to K into R1, S2 equal to K into R2 and S3 equal to K into R3. When I am going for the CMY, S1 equal to K into R1 plus 1 minus K, S2 equal to K into R2 plus 1 minus K and S3 equal to KR3 plus 1 minus K3. It is about the color transformation constant value. So here J of M, N is a output image, F of M, N is a input image. What is the transformation technique I am applying is a K. So here maybe K is a histogram. So the color transformation process the components of a color image within the context of a single color model. The formulation is a simpler and grade level to the transformation. G of x, y equal to T of f of x, y. Already we know that T is a transformation technique. So G of x, y equal to capital T of f of x, y. Here f of x, y is a color input image. G of x, y is a transformed or processed or output image. So input image equal output image equal to input image with respect to the transformation process. So what is the transformation process means? RGB, CMY or HSI or quarters of CMYK. So the transformation technique maybe RGB, maybe HSI or maybe I am taking a CMY. So these are the techniques. Any of one thing only I am taking. So RGB or CMY or HSI, any of that one I am taking. That is the triplets of this one. So these are the techniques I am applying for the transformation with respect to the output equal to transformation technique of f of x, y. So this transformation technique is applied to the input. Then only I will get the output. The output is maybe RGB or maybe HSI or maybe in CMY. So SI equal to TI of R1, R2, so on Rn. Here I equal to 1 to K, so on N. But here Ri is nothing but a component of f of x, y at point x, y. SI equal to color component of G of x, y at point x, y. So when I am taking f of x, y, it is about the input. When I am calling about the G of x, y, it is about the output image. So n equal to number of color components. Here I am taking n equal to 3, that is RGB. When I am taking n equal to 4, that is the CMYK. CMYK. So how many colors are there? 4 colors are there. So that is the reason I am taking n equal to 4. Here RGB. How many are there? Here 3 is there. Here 4 is there. So that is the reason I am taking n equal to 3. So when I am taking n equal to 3, that is RGB or HSI. So n equal to 3 means RGB. Red, green, blue. Or HSI. Hue, saturation and intensity. So n equal to 3. When I am taking the n equal to 4 means CMYK. How many are there? 4 colors are there. So I am taking n equal to 4. Here n equal to 3. So T is equal to T1, T2, so on Tn, a set of n transformations or color mapping functions to perform Ri to Si. So what is the transformation technique means? Si equal to Ti of R1, R2, R3, so on Rn. But here Si is the output image transformation process and Ti is the transformation technique. R1, R2, so on are the input image transformation process. So it is one example of input is a full color image process. Here I am taking converting to the cyan, magenta, yellow and black, CMYK. So cyan, magenta, yellow and black. K is I'm taking as a black image. So what is the input image is a color converting to the CMYK. What is a CMYK is a output image. So CMYK output. Here I am considering as a black equal to 0 and white equal to 1. It is one technique. And another technique is a RGB. So red, green and blue. So input image is a color image and output is a red, green, blue. So what I am applied? Here I am applied n equal to 3. Here I am applied n equal to 4. Why? Because here 4 colors are there. First color, second, third and fourth color. Here I am applied 3 colors. So output equal to, when I am applying the n equal to 3. So output equal to transformation technique of input image. So transformation technique is n equal to 3 applied. Here another one is a HSI. What is the input is a color image is a input. But what is the output here? Hue, saturation and intensity. How many are there? 3. So n equal to 3. So output equal to n of input. So n equal to 3 value. So hue, saturation and intensity. First image is a hue, saturation and intensities. So input image is a color, output are the 3 different colors are there. Hue, saturation and intensity. You can see the difference. Hue means here only black and white colors only. But here I am getting what are the shapes. So black is one image. So what are the blacks are there? It is one segment. Here you can see here the images, the segments are in the form of white. Here the segments are in the form of black. Here white. Here grey. So different colors are there. So you can, different segments are there. Every image looking like a different colors. But what is a common thing is a, we are identifying the image. We are identifying the segment. But what is the difference means applying the color. First image is also one item is there, round circle. But what is the color? Black. Here also I am identifying one image. But what is the color here? Maybe white. Here maybe the grey. So colors are different, but identification is a common thing. But here I am getting the black means when applying the hue, the image segment is a black color. When applying saturation, the image segment is in the form of white. When applying the intensity, maybe it is in the form of grey. So color image is converted to the 3 different colors. So the color transformation example, strawberry image I am taking in the previous. T1 equal to S1 equal to R1 hue. T2 equal to S2 equal to R3 saturation. T3 equal to S3 into KR3. It is the intensity. What is the condition? 0 is less than K and less than 1. When I am taking the RGB color means red, green, blue. So how many are there means n equal to 3. So Si equal to 1, 2, 3. So Si equal to K into Ri. When I am taking the CMY color process. So Si equal to K into Ri plus 1 minus K of input image. That is a I equal to 1, 2, 3. That is a CMY. I am taking 3 colors. So that is the reason K equal to 1, 2, 3. If I am taking the CMYK, then what is happened? K equal to 1, 2, 3, 4. So it is the figure A and the figure B is there. So what is the difference means I am decreasing the intensity of the left image by 30%. So left image is this one. What is happened means in the left image I completed 30% of intensity decreased. So compared to this one, the intensity of 30% is decreased. So when I am decreasing the intensity value, then it is showing as a looking like as a good image or brightest image or identifying image. It is somewhat so blackish color is high means the noise is occurred. So unidentifying. We are not identifying exact image. What is the image? But when I am decreasing the intensity, then I am getting the identifying image. So what is the apply here means RGB, CMY, HSI, HS and I. So there are different techniques. When applying the RGB, so the graph is like this. When applying the CMY, the graph is like this. When I am applying the hue saturation, when applying the intensity. So it is one technique, it is another one, it is another technique and it is another technique. 4 different techniques were applied to the original image to decreasing the intensity value of the original image. So, and it is useful to think of a color image as a vector value where the pixels is associated with the vector of 3 values. So each component of this vector corresponds to different aspects, color depending on the color model being used. So RGB model is a 3 values. So RGB is a 3 values, red, green and blue. HSI also have 3 values. Okay. So SI equal to TIF R1, R2, R3. Already we know that R1, R2, R3 are the input function, S1, S2, S3 are the output functions. So it is the output value with respect to the input with respect to the transformation technique. Okay. It is about the color transformation. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.